Hello and welcome to EBRD's COVID-19 Resilience Framework, Environmental and Social Assessment Training Programme. My name is Stuart Hume from Environmental and Social Advisory Services, or ESAS, and I'm a social specialist. Now, for the purpose of this video 4, Wastewater Collection and Treatment, I'm joined by my colleague, Mark McIntosh. Mark, please introduce yourself.
Hello, thanks Stuart. I'm Mark McIntosh. I'm an environmental specialist with background qualifications in geology and hydrogeology, experience in a wide range of areas, including lender due diligence, such as in this case study, and directing environmental and social impact assessments and investigations. And I've worked with EBRD for many years and very familiar with their PRs, so I look forward to discussing this one with you.
Thank you. So the purpose of this training video is to illustrate how EBRD's environmental and social policy and the accompanying performance requirements can be applied during an environmental and social assessment of a project within the wastewater collection and treatment sector. And the example that we use is the rehabilitation and expansion of municipal infrastructure. Let's now take a closer look at the project that we'll be looking at today. So, some key facts. The project involves the construction of 9 new wastewater treatment plants and the expansion of 10 existing facilities. The expansion of 2,200 kilometres of sewerage pipe network and pumping stations. The purchase of 400 evacuation trucks to remove sewage from remote rural areas for treatment at the new and expanded facilities. And the broader purpose of the project is to reduce pollution into a regional freshwater lake, a key economic resource in the region for fishing and tourism. And the project also involves a review and the identification of improvements to the client's operational procedures. And in fact, on that last point, this is an excellent example of the way in which the environmental and social assessment process covers a variety of topic areas, looking at the client's policies, their procedures in relation to labour, land acquisition, and management of contractors. So as part of this video, we will now look into the applicability of EBRD's PRs. So firstly, PR1, the assessment and management of environmental and social risks and impacts. Well, the project is classified as a Category B project, and the project is expected to generate significant environmental, social and health benefits. The construction works will also generate environmental and social risks and impacts. PR1 always applies, and in this case, an environmental and social assessment was conducted. PR2, labour and working conditions. Well, PR2 applies because the project involves the use of a workforce and multiple primary suppliers to provide various goods and services. And due to the large number of different companies involved, contractor management is going to be a key issue associated with this project. So Mark, in relation to PR3, resource efficiency and pollution prevention and control, please take us through as to why PR3 applies to this project.
Thanks, Stuart. Yes, PR3 applies because this project will aim to enhance the existing pollution prevention and control measures, so it will be a positive benefit to the project. It will also require the project to meet the EU Urban Wastewater Treatment Directive. EBRD's requirements for all its projects are to meet EU regulations around pollution prevention and control. And as part of the controls, the construction works will generate air and noise emissions, which will need suitable management plans.
Thank you, Mark. So moving on, PR4, health, safety and security. Well, PR4 applies to the project, for example, from the use of road vehicles on the public network. The workforce will be exposed to hazards associated with construction works, such as from excavations which introduce health risks, and also during the future handling of sewage using excavation trucks. And so there's a variety of sources of health and safety and security risks associated with the project, the latter relating to the use of security personnel. PR5, land acquisition, restrictions on land use and involuntary resettlement. Well, PR5 applies as well because additional land is required for the construction of new wastewater treatment facilities and also for the expansion of the sewerage pipe network. PR6, biodiversity, conservation and sustainable management of living natural resources. Well, PR6 applies as well due to the clearance of vegetated land which is required for the new facilities, and also from a significant reduction in pollution into the freshwater lake, which is of course one of the key project benefits. Now PR7, Indigenous peoples. Well, PR7 doesn't apply because there are no people in the project area that meet the PR7 applicability criteria. PR8, cultural heritage. Well, PR8 applies as well. There is going to be significant excavations and earth movements required during the construction of the new facilities and also during expansion of the sewerage pipe network. There is, for example, the potential for cultural heritage resources, archaeological artifacts to be damaged during the subsurface groundworks, and a chance find procedure will be required. So PR8 definitely applies. Now, in relation to PR10, information disclosure and stakeholder engagement, well, PR10 always applies, and in this case, a comprehensive public disclosure and consultation process was undertaken. There was significant stakeholder interest in the project, as the current wastewater treatment infrastructure is inadequate. And in a way, the applicability of PR10 also links back to the previous photo, which reflected the way in which there's a high level of pollution loading into the freshwater lake, and this is impacting tourism and other economic livelihoods. So that's a summary of the applicability of the PRs for the project. Now, in relation to this video, what we will now do is explore the application of PR3, resource efficiency and pollution prevention and control. And Mark is going to take us through the analysis of alternatives which took place during the early design of the project. So Mark, over to you.
So thank you, Stuart. We'll walk our way through the project in terms of the tasks we undertook. So the first task was the review of the existing documentation. From the outset, we put a request into the client to gain information and documentation from them, which would enable us to properly understand their current situation, to understand their current operational approach, current management systems, and gain as much of an insight into the project as possible before we started to assess the new proposed project. So we requested information around the PR3 aspects, which related to their annual resource usage of materials such as water, fuels, chemicals, and it also gives us an insight into how they're monitoring that. If they have that data, it gives us a good insight into how strong their management systems are. Similarly, around their waste inventory, details of their disposal facilities they use, and how they monitor their environmental impacts, and how they monitor their discharges into the lake, what chemical analysis they undertake, what capacity they have, and what their approaches are within their management system. And then we asked, ultimately, for the design of the project and the options and the alternatives, which they analysed as part of the design criteria assessment. So in terms of the analysis of alternatives, we looked at the pipeline network layout and its configuration. So the wastewater treatment technologies, how they were going to manage, treat, and disinfect the effluent which is coming out of their wastewater treatment plants, and the management of disposal of the sludge, which is one of the key outputs from these systems. We also encouraged them to look at the do-nothing option and assess that against the options on the table. Obviously, the do-nothing option was discounted due to the ongoing impacts to the freshwater resources, livelihood, and risks to the human health, which were one of the key criteria for this project being designed. So taking the network design and the alternatives associated with that, the underlying principle was to be compliant with EU's Urban Wastewater Treatment Directive, and of course compliance with national legislation. As Stuart outlined, the current situation was that there was an old infrastructure network which had been developed without a strategic plan and added to in an ad hoc and ill thought out manner. The result was a system which had serious maintenance problems, regular equipment failure, and was generating large waste volumes. The alternatives which were presented and considered were a local government master plan and a national water organisational plan. The solution and the conclusion was that taking the national water organisation plan was the preferred option, as it avoided being constrained by local administrative boundaries and it achieved the most efficient use of existing resources. It resulted in minimizing the number of wastewater treatment plants which would be required in the rural areas and decommissioning of the small wastewater treatment plants in individual villages by replacing them with pumping stations which would maximize the use of the larger wastewater treatment plants and therefore increase efficiencies in the system. It also decommissioned and replaced the poor state wastewater treatment plants, which were the fundamental cause of much of the pollution going into the lake. And there was also a modification of the connections within the villages not currently on the system, so that the sewage could be collected locally and efficiently from those. So the network design considered in detail resource efficiency and pollution prevention and control in its considerations of how the system would work to its best efficiencies. The wastewater treatment technology alternatives which were considered, again, the underlying principle was compliance with EU's Urban Wastewater Treatment Directive, and also how it applies to nitrogen and phosphorus, which were the key drivers for the algal blooms within the lake. The old infrastructure, with its underinvestment and poor management, did not allow efficient monitoring of the discharges, and there was a lack of laboratory capacity to monitor how well their systems were performing. As it was old technology, the alternatives looked at enhancing it through standard biological treatment technology or advanced biological treatment systems. The ultimate solution was the rehabilitation and expansion of the existing plants, adding in new technologies, but also enhancing the staff training. There's been an underinvestment in staff training, their understanding of technology, their understanding of how efficiently wastewater treatment plants can work. And combined with that, there was a need for them to be trained in the use of the new technologies. Considering the alternatives for the management of the treated effluent, the actual current operations were using the effluent for irrigation on agricultural land. This was causing problems due to the nitrogen and phosphorus pollution running into the freshwater lake. And this was being enhanced by untreated domestic wastewater discharges going into the lake. So the alternatives considered were actually discharging it away from the lake through a drainage system, or treating it to a higher quality and reusing it for irrigation purposes, but excluding edible crops due to the risks for human health and that. And ultimately, the option chosen was one which was higher levels of treatment of the effluent and to use it for irrigation of edible crops, which was an important element for the stakeholders involved in the farming sector, because it gave them an ability to use irrigation on their fields, which didn't require extraction from the lake itself. The management and disposal of sludge was a key alternative to be considered. The current practice was finding that a contractor would collect the sludge and was responsible for selling the material to use for agricultural purposes. However, whilst the contractor was liable for the quality of the sludge he was taking, there was no information on testing for pathogens or heavy metals due to the lack of laboratory equipment, and therefore the suitability of the sludge for the agricultural use could not be determined. And due to the knowledge that many sludge was coming in from industrial areas, there was a concern that heavy metals were being spread onto agricultural land. and causing pollution of that land from those metals. So the alternatives which were considered when looking at the redesign of the system was to look on add-on technologies, firstly to reduce the sludge, such as through anaerobic digesters, which also had the potential benefit of being able to generate methane, which could be used as a biogas. There was a look in the design of the system to separate the industrial and public sewerage systems. This, it was found, was a straightforward approach to take because the industrial areas were very focused, and therefore it could be dedicated to a particular wastewater treatment plant, and therefore removing the risk of contamination of sludge, which might be used for agricultural purposes. There was consideration of not using it directly in agriculture, but also using it for land farming or restoration, such as to bring brownfield sites back into public use. There was also the consideration of landfilling or incineration, but these were dismissed as the landfilling would firstly use up valuable landfill space. It would also potentially generate methane, which was uncontrolled. And the incineration, there was concerns around that with respect to control of the discharge of the emissions from the incinerator and the metals within it. Ultimately, there was a sludge management strategy developed, which broke down the uses for the sludge and the most appropriate destinations for it to be used. So we now think about when we go and visit the site and how PR3 is considered during a site visit and the discussions which happen on the site. The key findings associated with PR3 from a site visit can be really broken down into observation. When you're on site, you're looking to evaluate the operations and their key inputs and outputs, and put an understanding of all your documented research in place. You'll also be looking to evaluate their management systems and monitoring, and how well their systems approach the PR3 issues. Do they have the laboratory capacity to do the testing of the effluents, the sludges, and the various steps within the wastewater treatment plant? And do they have the knowledge then to apply the results of that and inform their management system and improve the performance of their wastewater treatment plants? And then ultimately design how they will dispose of the sludge and the effluent. The site visit will give you a strong appreciation of the environmental setting and whether the alternatives selected are adequate and correct and appropriate for the site setting, be it the proximity of the lake or the discharge points. The discussions with operatives should always be encouraged. You can gain an awful lot from understanding their insights into the challenges of running a wastewater treatment plant and how well trained they are, how knowledgeable they are, and whether there is a strong need for further training to enhance that. You need to record and take extensive records during your visit. Take photographs, even of the most benign things, and lots of notes. These will support your interpretations and the recommendations made. Your recommendations have much more impact if you can actually demonstrate through photo records why you're making them. One of the challenges of PR3 is actually the time it takes to visit a project. And a project such as this, with so many kilometers of pipeline, so many proposed upgrades to wastewater treatment plants, you need to design your time in the country efficiently so you visit the key elements to gain an appreciation of the project. So if we think about how we analysed and reported it using EBRD's format and the recommendations within the Environmental Social Action Plan, there needed to be a resource efficiency department. There was a lack within the management team, individuals and skills to really manage the elements of PR3. Built into that, really, of a need for capacity building for personnel on energy and resource efficiency. This had not been considered in detail by the previous management. And with a new system coming in, it was important to actually ensure it was running efficiently. People were monitoring and mapping out the resources used and looking to develop key performance indicators, which demonstrated they were improving efficiency as time went on. The timing of the intervention from EBRD and the audit meant that we could incorporate feasible resource efficiency measures into the design of the proposed wastewater treatment investments before they were made. Similarly, we can influence the effluent reuse options into the wastewater treatment design operation. So it's efficient if we can be involved in a project from an early stage and be able to engage with the design team to inform them of our findings. Similarly, incorporating necessary pollution prevention measures into the design of the proposed treatments, wastewater treatment. It was designed at the start and the right options and alternatives were taken account of. We recommended they implemented a treated wastewater quality monitoring system, improving their laboratory testing, so that they could have a better and more confident appreciation of the quality of the effluent they were discharging, and importantly, ensure they were meeting the EU directives. We required them also to develop a greenhouse gas inventory for the project. That included both direct and indirect emissions, and included those from the anaerobic wastewater treatment systems which were being installed. As part of the spot sampling of the various sites, it was identified that their control of oil, fuel, and other chemical storage areas was very poor. And one of the recommendations was that for the whole project, there needed to be a detailed review of the bunding around their chemical storage areas and the delivery areas, and what their spill response procedures were and how they were implemented, and whether the staff were suitably trained in their implementation.
Great. Thank you, Mark, for the detailed explanation on PR3, resource efficiency and pollution prevention and control. And so this final slide is really just to reinforce that whilst we have looked at PR3 in some detail in this training video, the majority of the PRs do apply to the project. And as I said earlier, the project was an excellent opportunity to undertake a rigorous review of the client's environmental and social policies and their procedures across a range of topic areas, not just resource efficiency and pollution prevention and control. So this marks the end of the training video. I hope you've enjoyed it, and please refer to the other resources on the website. Thank you.